Hello everyone, my name is Julian from the Chair of Product Development of the TUM. In the next couple of minutes I'm going to present you an overview of the research we have conducted in sub-project A10. We investigate how use phase data can support systemic PSS innovation, what challenges lie ahead and how we can solve them. During my talk I will use the example of a bike sharing system to illustrate the challenges and the solution approaches. The current changes within the product landscape are visible to everyone. Products not only consist of physical parts, but also parts enabling constant data gathering and connectivity. This connectivity provides PSS providers with the constant gathering of data and use phase data. In our research, we define use phase data as all data originating during the use phase, from the physical product itself and the related services. Especially important is data stemming from user interaction. Use phase data has great potential to support internal as well as external stakeholders. By analyzing use phase data, providers can improve their current and future PSS offerings based on insights gained from the data. For example, the data can be used to formulate more user-oriented requirements, tailor services offerings to concrete customers. As an example, could be the service of a bike sharing system. In general, many different use cases exist. Our research motivation is that the availability data provides high potential for supporting PSS innovation. However, our experience shows that companies struggle to translate their questions into the domain of data analytics. One key challenge is the interdisciplinary collaboration required to fully realize the potential of data-driven insights. Associated with the endeavor of integrating use phase data into product development are the number of wide-ranging changes affecting the PSS itself, but also the organizational and process structure of a company. Based on this research motivation, we derived the following research objectives for our sub-project. In order to support companies in successfully mastering the digital transformation, strategic planning is necessary. Companies further need to identify use cases and systemically derive implementation plans to realize them. Modeling the use phases is an important step to understand existing potentials as well as areas of future improvement. In order to analyze the possible range as well as the future system behavior, means and methods to design corresponding analysis scenarios for data need to be investigated. Eventually, in order to ensure the implementation of the identified use cases and derived methods, pre-existing design processes within an organization need to be tailored correspondingly. Now, let's look at our example again. Running a bike sharing system leads to various challenges for planners, engineers, and designers. Bike sharing systems in larger cities consist of a number of stations with different sizes based on demand. The cyclic nature of different influence factors lead to a complex dynamic behavior of the bike sharing system that is not always predictable. This should just be an overview of the possible changes in PSS design. Looking into possible use cases to take advantage of use phase data in designing a bike sharing system, data can help to identify the optimal location for bike stations based on user flows, demand, and points of interest. Looking at cycling influences, the optimality of the station distribution might be time dependent. For example, large-scale events might make a temporal change in station layout necessary. Associated with the station layout is the relocation of the individual bikes due to variances in bike distribution over the time, which needs to be efficient as possible. As a third aspect, planning needs to be, or maintenance needs to be efficient, and the capacities need to be planned in a suitable way. As I mentioned before, the PSS innovation process contains a number of decision points and questions where we can data integrate. As means to integrate this data, models can be used. This is especially useful in order to conduct experiments regarding the system behavior, since PSS are often too complex and experiments in the real world are often too risky and quite expensive. Here we have described a systemic procedure that on one hand addresses the systemic development of models as well as the corresponding steps to integrate use phase data. It is first necessary to derive and document the need for data gathering, the problem situation. Afterwards, data needs to be mapped. This step needs to be executed every time the available database changes. The data needs to be treated as to a specific problem. For example, it needs to be cleaned out of outliers or formatted. The data is applied in the context of model creation. For example, data regarding the bike rentals can be used in order to build a model of the occurring demand. Along with the model testing, the applied data needs to be evaluated. Once the model is in use, it can be further identified whether the model can benefit from further or different data, whether the quality can be improved, and other examples are possible. This can be used then to further develop the database on a need-oriented basis. For dynamic modeling, we have applied two different paradigms: system dynamics as well as agent-based modeling. System dynamics is more concerned with giving a strategic overview and focuses on the aggregated behavior. Inference of individual behavior is not possible. Using agent-based modeling, however, the behavior of individual agents is explicitly modeled using rules, for example, drawing a state chart. Agents, such as individual bikes, can subsequently be placed on a map and their behavior can be observed and recorded. In both approaches, parameters can be systemically influenced, for example, to simulate the cyclic inferences or to performance of the service processes in order to investigate the system response. There are insights that can be used for system innovation. Use phase data can be used in order to create a realistic basis for modeling, for example, to derive realistic coefficients for bike malfunctions, rentals, or service times. The previous slides just gave an overview of possible use cases that allow PSS providers to take advantage of use phase data. However, our experience from industry collaboration shows that companies struggle to identify suitable use cases and assess the related implications for the organization. The slide shows one of our current research results. The depicted process model assists companies in developing a tailored use phase strategy. From our perspective, a use phase strategy is important because it supports companies in identifying suitable use cases, performing a structured evaluation of the use cases, integrating the different stakeholders, planning the implementation of the use phases. Overall, the process model especially helps companies unexperienced with data analytics to derive a suitable path for extracting value from data. Our research project will end in December 2019, and until then we will further work on support that allows companies to master the challenges connected with the digitalization. I hope in the last minutes I provided an interesting summary of our research motivation and goals. In case you have any questions or comments, please feel free to contact us. Thank you for watching our video.